First of all, welcome everybody to General Dynamics. I didn't have to walk too far to join the meeting today, so I thought I'd join you. Just a little bit of my background as well. I've actually worked mostly in the defense industry here in the Twin Cities for many companies, quite a few companies, Honeywell, and a little bit of time at BA Systems and Goodrich. And mostly systems and software engineering. So what Paul asked me to do tonight was talk about what we do here at General Dynamics. And so I've got a few slides. He says they're mine. We'll see. So at a high level, this is what General Dynamics is. And you may or may not know we're one of the big four defense companies. And we're pretty broad in what we do. We actually own an aerospace company called Gulfstream, for example. So we make commercial business jets, one of the best. And that's our aerospace division. We have combat systems, which is our land systems that make the Abrams tanks, Strikers and other vehicles. We also have a shipbuilding business called Marine Systems, and they make nuclear-powered submarines, and they make destroyers and other surface ships, some commercial as well. And over on the far right is information systems and technology, and that's where we fit in. There's several divisions in there. We're advanced information systems, and we've got two buildings here in Bloomington. And the one you're in here, the old high school, BLC, and you've probably noticed the four bears up here. The agreement back in, I think it was 81, and actually Dave Walden, who was a GD here, employee here. I know he spent a lot of time in this building. You might know the story as well, but apparently when we bought the building or leased the building, they said we couldn't cover the bears, so this was the Bloomington Lincoln mascot, thus the four bears. So we've also got a building over on Hampshire Boulevard, south of the park over here, and that's our factory. We've got several hundred people there, and they build the stuff that you see on the walls here. We make computers, and I don't want to make assumptions, but I think some of you are old enough that you might remember Control Data. And we are part of what used to be Control Data, and for those of you that don't remember Control Data, it was one of the first supercomputer companies, and it was based here in the Twin Cities. Seymour Craig got his start at Control Data. There's, I think, about 40,000 employees at the peak, and about 10,000 here in Minnesota. It was a big deal. And now medical devices are big in the Twin Cities. At one point, computing was huge. And we, believe it or not, we still here in Bloomington make supercomputers of various sizes, and for very important customers. And some of them are on the walls here. We make computers that go mostly in aircraft, spacecraft, and also for some proprietary customers. So we're still doing that. So Integrated Tactical Solutions, ITS, that's what we do in Bloomington. You can just see in Advanced Information Systems, there's several divisions, and here in Bloomington we're ITS, Integrated Tactical Solutions. I will say that we also support another division, which is our cyber division. We have a lot of folks that are supporting that as well. We build a littoral combat ship, or at least we integrate, and I don't know if you guys have followed this in the media, but this is one of the Navy's newest ship actually, and it is being developed to address really the asymmetrical threat out there today, where you have combatants that you need to be able to get in close to the shore, do your special operations, deploy people, get them back quickly, and worry about things like some of the submarines that are out there that can take on carriers and have some capability that is no longer deep water. Back in the Cold War, the threat was deep water. Now it's shallow water. Littoral combat ship is designed to go into those areas. And General Dynamics is integrating the electronics on that. And Austal, a company based in Georgia, is actually, in Alabama, is building the boat. So we have a big part in that. That's one of our newer programs. Not let out of Bloomington, but we do have a part in that as well. So here in Bloomington, I think I talked about control data, and we've had quite a bit of growth here in the last 5 years. I will say that just in the last year, if you had heard about Future Combat Systems, that program has been canceled, so we have done some consolidation recently here, just this year. But we have a very large presence here in Bloomington. It's not something you hear about a lot of, but we are here. So most recently, it's kind of hard to see, but our new factory that I mentioned on Hampshire Boulevard just a few years ago, we built that factory, and that's where we build our high density circuit cards that we design here, and we package that up into line replaceable units. And again, some of the pictures are on here, and I can't remember these slides, so there may be some pictures in here as well. And we test them and deliver them to our customers. So one of the interesting things is that we've done the mission computer for the F-18 fighter for going back to the 70s actually, and the Navy standard computer for airborne applications. And that is a requirement for 20-year life. So you can imagine that that's pretty tough to do. And the last several iterations of that computer have been using commercial parts. So how do you take a commercial part and deliver it for 20-year life? It's a challenge, but we've got some capability to do that. We've got a lot of patents in that area as well. How do you mount a commercial part on a circuit card? How do you make it durable and rugged? So that's really our specialty. So what we do today is we do mission computing for things like the F-18, actually for spacecraft as well. We do rugged data storage. We have data storage on the Abrams tank. So historically that's been spinning mass. So again, how do you take something that's a hard drive and put it on a tank and make sure that it first of all doesn't break, but that it lasts a long time as well. So we've been doing that. Of course, we're going to solid state memory now. Weapons management system, primarily on maritime patrol aircraft like P3, and we make the computers. Some of you in the room have worked on that. We make the computers, the displays, the user interfaces, and deliver that complete system to the Navy. And I mentioned space payloads as well. We've got some unique architectures to make sure that you can either handle high radiation or you can recover from any kind of failure. So very rugged, durable computing, high performance, high density, dealing with thermal, and really the long life, and it's computers that have to work. Blue screen of death is not acceptable in our line of business. So airborne systems, these are some of the aircraft that we're on and some of the platforms. The interesting thing is I actually got my start as a systems engineer at Honeywell working on the Mark 50 torpedo. And this company, General Dynamics, made the AYK-14 for that torpedo. So it wasn't just airborne, it went on a lot of different platforms, and we're still delivering computers for those. And I remember the day when we got the round hardware, because a torpedo was round, and so they made a special circuit card for that, and that was a big deal. So as far as engineering, we've got about 270 engineers here working in systems, software, hardware. We do everything from circuit card design to packaging. How do you package for 20-year life? How do you take care of the thermal management? All those kinds of things. We've got full life cycle capability here. We have several labs, including signal integrity. Our latest open system processor is a 21-layer card. It's got 2,500 parts on it. It's 6U form factor, and is actually the highest performing per watt module on the market today. And so it's very high density. You have to worry about things like thermal management, signal integrity, to make sure that it's reliable and can operate at the high frequencies that we need. What else do we do? We are, what's that?
Software.
We do a lot of software. And the software really is everything from the operating system that we might deliver with a card and the customer puts their applications on top, to the drivers, to the software that actually is very close to the hardware. In some of our high performance computing, we actually do something that's called microcode, I believe. So it's very close to the hardware. So everything from very low level software to drivers to actually delivering COTS OSs, optimizing the OS. We did a Ethernet switch module for the latest architecture for F-18, and we used Linux, and we also used a commercial switch, and we embedded that on our own module and got the startup time for that switch from over a minute down to 6 seconds. So those are the kinds of things that we have to do. Fast startup times, high reliability, optimizing OSs for real-time performance. So, and then we also do the application development on top of that for some of the systems. We are a CMMI level 5 organization, and we've been assessed at CMMI level 5 twice now. The last time here a couple years ago, and we'll likely be going for reassessment here next year, since you need to do that every 3 years. Let's see. Better keep going?
Yep.
Okay. A little bit of what we're doing here to refresh our technology and where we're investing. I mentioned the OSP. We also are looking at a secure CSS, which is our API layer of software, and our most recent version of that supports multi-core and secure separation kernels. So we were looking at separation kernels and integrating separation kernels from both Green Hills and Wind River to accommodate both safety and information assurance or MILs. We're also looking at, we have an IRAD that's been multi-year now that's actually looking at secure networking so that you can actually have multiple levels of security, or whether that's unclass, secret, top secret, or maybe you have different caveats, different ways you want to classify your data, that you can mix all that data on a single network. The way it's done today is that in order for communications to happen across the network, you have separate networks with guards in between them to make sure that the data can't cross. We have a way to combine all of that, so you can imagine that would save a lot of hardware costs. So that's an area we're investing. We are in the process of getting reviews with the NSA to move towards certification. We're also looking at secure storage, and that's using encryption and labeling as well. We are looking at the next generation of armament controllers. So I mentioned the P3, controlling multiple stores, different kind of weapons and sensors. We are looking at, you've probably read or heard a lot about what's happening with UAVs. Those are the next platforms that the military will be building. They have a lot of sensors on them. Today they want to weaponize them as well. And so we're looking at building the next generation of small form factor computers to accommodate the smaller platforms. So we're investing in that. And we also are looking at display processing using open standards for both the GPMs as well as OpenGL software. So we will now have display and video processing on the F-18 here with our Type 4 computer, which is the latest architecture for the F-18. We hope to take that to other platforms. So manufacturing, again, I said that we invested here a few years ago in a new factory. We build the circuit cards, we test the circuit cards, we integrate into the box, we test the box. We have a dozen ovens and shakers, and sometimes we combine them to do screening. We have a lot of development test assets, including a large shaker, and so if any of you need some testing done, we'd like to hear about it because we can perhaps accommodate that. So a lot of that stuff does sit idle for the development. The factory stuff is always going, the development stuff, not so much. But we have all of that capability here, either in this building, we do have some labs, but most of it is at our factory. So.
Okay, so I thought what I'd talk about, at least one of the presentations, a little bit about, you know, leadership back in the old days. It's not what leadership is today, okay? So back in the old days, I'm only talking 30 years, this right here is what we thought an engineer was, a systems engineer. I don't know about the companies that some of you that have been around have been at, but my company had one system engineer for all of business and regional aircraft. One. And he was the go-to guy, he was the leader, and he looked just like that, right? And this is fairly typical about system engineers. You know, a group of them will get together and they'll go to lunch and they'll order pie, and that's exactly how they'll do it. So I'm sure you can relate.
Hit something there.
Oh, oh.
Hit the advance. There you go.
Oh, there we go. Okay, so I wanted to show you a little bit about what leadership is today. So it isn't some guy sitting in an office somewhere trying to wait there for people to come talk to him about something or other that they need a system engineer to show leadership on. It's this group right here in the middle. Let's see, does this have a pointer on it?
I don't think so.
No? Okay. So we've got a gray beard. They're still part of it. You know, we have a few people that kind of look like that first guy, but it's a group of people. It's a very large group, very diverse, right? So you start in the upper left-hand corner, you have very mobile leadership. You know, today we have a lot of wireless things. You don't just sit in an office. You can take your office pretty much wherever you are. Airports, people who travel, right? That's what happens. There's virtual leadership. You may not sit in an office. You know, you may sit at home, wherever you are, and you may be talking to people that you never meet, ever. You know, my job these days, I work with 18 different sites. Most of the people I will probably never meet. But it's a different kind of leadership. It's a leadership where they don't see your body language. It's leadership where they only hear your voice. You have teams assigned to you. You don't know these people. And yet, somehow, you're the leader. You gotta lead. There's global leadership. Not only do we deal with mobile and virtual leadership, now it's around the world, right? So now you've got accents, you've got time zones and everything else thrown in. So when I first started the System Engineering Competency Working Group at INCOSE, I thought, great, you know, we're going to organize this, we're going to have telephone calls. You know, I know it's around the world, but when you have people from Australia and Singapore and Israel and the East Coast and the West Coast around the world, it doesn't work. So we have to deal in ways that are not the typical. And then social media. Oh my gosh. I don't even begin to understand where that's going. But I can tell you the leaders of our future are going to be very adept at using that somehow in the workforce. I mean, we use it to a certain extent, but I don't believe we tap everything. And oh, by the way, faster, 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 everything we do. We don't have time to define the interfaces, right? We don't have time to communicate, right? So where's that going to go? And I know Paul said that leadership is not something that's in the system engineering training, but it's becoming more so. So if you go look on the web, you know, NASA certainly has identified system engineering and leadership skills as being a critical part of it. Same with the Defense Acquisition Guidebook, the System Engineering Chapter. There's a gentleman at MIT, so academia that recognizes it. And I know BAE Systems and Lockheed Martin both have leadership programs around system engineering. So I suspect others do as well. Okay, so I have a bunch of questions that I can put up here, but I'm going to stop for now and
Okay.
we'll move to the next one.
I didn't realize that I was supposed to prepare some talk, so I quickly scribbled notes in the back of the room.
Option.
Yeah.
It was option.
Okay.
You did okay.
You sure this is,
Huh?
you sure this is?
Well, I didn't want leadership.
So I started with what is systems engineering, and in my recollection from about 30 years ago was even worse than some of the bad views of systems engineering that have been talked about here. And 30 years ago, a systems engineer was a scribe who worked in the back room to maintain the interface control drawings. And that's all they did. And I got so annoyed at that view of systems engineering, I actually changed my business card so that now it says systems architect. Right? But things have gotten better, and maybe because influence of INCOSE, but I think over the last 10, 20 years, the view of systems engineering has gotten a lot better. But even in kind of the systems engineers really are a diverse set. You know, there's ones that deal with process and product, and I'm kind of on the product side, and again, as a systems architect. But even as a systems architect, you know, what does a systems architect do? And I run into management misconceptions there where they fall to what I call the George Carlin fallacy. George Carlin had this shtick about you nail two things together that have never been nailed together before and some schmuck will buy it. And there's a lot of management that think systems engineering is just hooking things together that have never been hooked together before. What's so hard about that? They're just boxes with lines between them, and you just fill in the box the name of what the box does. What's so hard about architecting? But really, a systems architect is more like my father's version of what a farmer is. You have to be a jack of all trades and a master of most. And being a master means you aren't an expert, but you have to have enough mastery of a number of different disciplines so you can talk to the experts, so you can interface with the experts. One of the things I run into a lot is what's the value of systems engineering? Management sees it as a cost, okay. Really, it's an investment. And so you have to continuously tell management it's an investment. And you have to keep showing them the plots of here's the cost of fixing a bug as you go through the process of designing a system. And you catch those system problems early, they're cheap to fix, but when you get into the test and integration phase trying to fix an architecture problem, it's horrendously expensive. There was some talk earlier about changing requirements. And that is a problem, so you'd like to solidify requirements. That's one solution. Another solution is to architect a system that's immune to requirements changes. And so a really good architecture won't have to change because the requirements change. One of the problems with organizations putting off doing systems design and waiting till it costs a lot is what I call technical problem procrastination. Instead of attacking the hard problems first, they attack the easy problems first, because then to management it looks like you're making progress. You solved 6 problems today, whereas the one hard problem would have taken you 6 weeks. And so that's something that we have to fight against as systems engineers, is go after the hard problems first. The next thing I thought about is what is architecture? And I disagree with a lot of views of architecture as architecture being kind of hierarchical design where you have a high-level design and you refine it down to lower level. To me, architecture is really meta-design. It's the design about design. And so architecture is to design as the Constitution is to law. The Constitution isn't law by itself, but it tells you what the rules are for creating laws. And the same thing with architecture. It isn't a design. It tells you what the rules are for making a design. And the last thing I want to talk about is leadership. There's a number of aspects of leadership. One of them is you have to be able to talk truth to management, and sometimes that can be tough. I know I was in front of a group of Honeywell managers, and I told them that there was a problem in one of their processes. And one of the managers suggested I be fired for, showing that the emperor had no clothes. But looking back on it, I think I had a moral responsibility to stand up and do that, even though I was, threatened to be fired for doing that.
That's nice.
Yeah. Another thing about leadership is inspiration, and we'll talk about inspiration earlier. And part of inspiration is having a vision and being able to have others share in your vision. So you have to give other engineers an idea of where you're going and some reason why you should be going in that direction. And finally, the last part of leadership is being able to be a mentor. I'm getting old enough now where I can look back at my career and say, what have I done? What are my significant accomplishments? And I can look at things I've designed, awards I've gotten. I can count how many patents I have. But really, the pinnacle of my career, I think, happened last year. I gave a talk at SafeComp over in Europe, and after the talk, a young engineer came up to me and said, "You've changed my life." And so how many of us have inspired a young engineer to change their life, to look at the world in a different way? Thanks.
I guess the question I'd start with is, what does leadership mean to each of you? To me, leadership and system engineering are somewhat synonymous, but yet in some respects they're very different. Because leadership is when you're given a task to do, making sure you get it done. System engineering is applying leadership in one area of the business and maybe not in another, but working with others, working through difficult situations to get a job done. I'm in an environment right now where I'm given tasks to do. I have no cost budget to deal with. I have no staff to deal with, but yet I need to get other organizations to contribute to getting a job done. And so leadership is working outside your bounds, working outside your comfort zone, and working in an environment that doesn't understand system engineering at all, but yet trying to get these people to understand why you need to do what you're doing, the process steps you need to go through, the benefits that you achieve by accomplishing these tasks, and yet getting everyone to work together on a team to accomplish the end objective. Even though it's not high on their list of priorities, even though it's not important to them personally or within their groups, but yet bringing this group of people together to function as a group to getting the job done. Again, soft skills versus hard skills. I think soft skills are much more important than the hard skills of system engineering, because you need to be a communicator, you need to be a driver, you need to have that interdisciplinary knowledge so that you can communicate across disciplines. I'm also working in an environment right now, a lot of what Paul talked about sounds great if there's a common understanding of what system engineering is or should be within the organization. In the organization I'm in right now, we're trying to bring system engineering into the organization, to bring more system engineering content to our programs. So it's a learning experience for our managers and their managers also. And a lot of times those of us that are, quote, system engineers, unquote, we try to do things, we try to accomplish things, but our managers see no reason for doing that. They don't buy into it. So we first have to be the leader to communicate with our bosses to get them to understand why we need to do what we do. And then hopefully, through a few iterations of this, a few lessons learned, a few times of not doing it, hopefully they'll understand that maybe we should have done this all along. And you just have to keep pushing. And you have to have that consistent approach to life that you're not going to accomplish everything you want the first time around. So you have to have the tenacity to be persistent. So again, to me, the leadership and system leadering, when they do come together, it's more than soft skills. It's team leadership. It's working with your bosses, working with other organizations, and just solving the issues that arise. I guess jack of all trades is a good way of summarizing what a system engineer really does, because on the program I'm on, a lot of times if a task comes up and my boss doesn't know who to give it to, it comes my way because I'm a system engineer. And so it's really a jack of all trades type of approach, because again, the company is learning. And we're trying to be successful in how we apply system engineering, but yet we've got a ways to go.
Thank you. You want to go to your slide? Your slide?
But
I also
we
think
can
it's
start discussions, but figure, I guess, the whole intent is to try to talk, Neil asked the audience about, what do you think leadership is? So on the left side is leadership. Leadership is not management. And that's said.
Use
So
the
I
microphone.
emphasize
Use the
both
microphone,
sides.
please.
What?
Microphone.
Can't hear you, Eileen.
Okay. Leadership is on the left side. That's what I'm trying to emphasize. Leadership is not management. You can see that. And this is some additional ideas on what leadership is. Neil had asked the audience, well, what do you think it is? So I thought I'd throw this up here and we could open it up to the audience.
Portable mic person, now it's time for your participation here. Questions of the team or anybody?
You've got a good voice, but I'm going to make you use
I
it.
don't know if you need that.
This is for anyone at the table. My viewpoint on systems engineering has long been that when you look at the overall management structure, you always think of the program manager is at the top, in charge of everything. My outlook is that in an ideal world, the top position ought to be, if not a systems engineer, the top systems engineer. In other words, program management is just one of the many regimens that jack of all trades has got to be able to guide, manage, and take into account. So I was curious what the panel's outlook on that is, if you would agree.
I'm actually writing a paper on this, just that topic, because I am a certified PMP, program manager, and also expert system engineering professional. But my job at work is mostly with the program managers, and it's dealing with conflicts with the system engineers. But some companies recognize that. Lockheed Martin is one of them. At one point, I think they're moving away from that, from what I hear. But before you became a project or program manager, you had to be a chief system engineer first. And so they had a program in place to do that. So I've heard they don't. If somebody here is from Lockheed Martin, although probably not there, maybe it's former, and know differently.
They are moving away from that.
Yeah, okay,
They
so
want
it's been
more-
confirmed.
More business types.
Right, so that's what I've heard. From my perspective, system engineers the focus is product. Project managers, program managers the product manager is the biggest, the system engineer is the biggest piece that they would have to manage. That's why you have a separate leader and manager doing that. But the program manager should be worried about other things. They shouldn't be beating the system engineer, the lead over the head, chief system engineer, saying, "Are you done yet? Are you done yet? Why aren't you done yet?" Right, they need an understanding of what that is, and they ought to be helping to get them there if they can, or recognize the schedules may not be commensurate with the technology risks that may be inherent in development.
It was also interesting, a few years ago, in another lifetime, I was working on a system engineering plan as part of a proposal activity, and it was a defense acquisition system for the Army. And in the SEMP, they did ask that as part of the SEMP, the program plan, the program management plan was part of the SEMP. So the system engineering plan, in their instance, was a higher guiding document, higher guiding plan than the program plan. So the program plan, the risk plan, the software development plan, all the other plans were low-level plans in accordance with the SEMP. So they were recognizing themselves the importance of system engineering.
And there's lots of arguments back and forth on that. Basically, it's the billy goat on the hill trying to knock the other one off.
One last idea, the systems engineer should be responsible for making sure the system is designed and built correctly. And program management should make sure that there's sufficient resources to do that job.
I guess this could be to anybody on the panel, but primarily when I heard about your certifications and what you've also had, would probably be for you as Eileen. With the talk and mentions of systems engineers and engineers in general having very lacking interpersonal skills, the soft skills as they were put, in order to actually lead and take these positions on. And then you see such things as your systems engineering certification or your PMP. Which parts are the most empowering when it comes to getting to the leadership? Does this systems engineering certification that INCOSE actually puts out endorse and allow the leadership skills to actually be cultivated for a systems engineer? And where did you find yourself finding the leadership abilities to do what everybody here is preaching we should do?
Okay, that's pretty loaded. Okay, first of all, the SE competency working group that I started in COSE, we have a competency framework that the UK chapter put out there as a start, and in it is lacking soft skills. They do say something a little bit, I think, about leadership or maybe management, so it's kind of a move towards it. It's not something that was always there. You're kind of at the forefront. The certifications, they kind of allude to leadership, but the ESEP, the Expert System Engineering Professional, that's kind of the cornerstone. If you just sit in an office and crank out stuff, an ESEP is not supposed to be more of CSEP, which is the basic level, if you will, of certification. So the focus is leadership. How do you learn soft skills? I guess the big thing is you learn to listen, and people want to be heard. I bet you've all had instances in conversations where you couldn't get a word in edgewise, or your point was made and somebody dismissed it instantly and walked away from it. So leadership, the soft skills, are really cultivating some of those skills to give people what they need to feel good about themselves. So You want somebody to walk away and feel really good about themselves. You know, that's the essence of it. Yes, you can learn it in classes. It's easily forgotten in a firefighting mode, certainly at work. But some people are potentially predispositioned to having those skills. So. Did I miss anything on your question there? Do you want something more detailed?
Something kind of under-addressed in this that I'm curious about is how do you push the buy-in to upper management to allow the technical people to take the reins and organize a project? The bulk of my career has been at the DOE National Labs, and when people with engineering backgrounds got to take over their projects and their programs and organize them, they fell into a very nice matrix management style where everybody worked on more than one project. Most people didn't work on a single one. And they had the ability to be leader on some and subordinate on others. So you had this natural place, a structure to develop your leadership skills, but it wasn't the only thing you did. What we found out is those projects were the most successful, the most on schedule. Management up above that absolutely hated it because they wanted to see people in either leadership roles, strictly management, or technical. The technical people absolutely resisted that constantly because you'd lose your edge. If you went into management, you were in a pigeonhole for the rest of your career. You had to really be careful about how you handled that. So you needed this real buy-in from up above, saying that when it came down to planning the projects, showing the leadership to actually seeing them done, but then managing the technical aspects, there was always this battle back and forth. How do you see this work effectively in private companies and businesses?
I think you have to look at what leadership means to your management. And what management, and especially senior level management, really cares about is performance. Performance in terms of getting something built on time within budget. So you're looking for a project manager. And yet your technical team needs the technical leadership to solve the technical issues. So you're balancing that level of leadership that you're doing on a day-to-day job with your coworkers against that what your upper management really is looking for. And that's really, I think, two levels of leadership. And in response to the earlier question, I think as you rise in the ranks of system engineering, you're doing less and less technical activity and more project management of the technical activities. Yes.
I was just going to say, or leadership. So, you know, when you're an engineer, you're developing things, designing things, working with engineers. But as you get further up, you know more. And you get more into a mentoring role that's more leadership. You don't necessarily need to have people report to you. There's a lot of staff positions that really require the leadership. Because Neil was just telling me, is that just such a story when we walked in tonight?
It's just a comment.
This is not a question, but just a comment on the same overall question. One thing I think you can do as an individual to improve your soft skills is not be afraid to volunteer, to work in or do things that you're not totally comfortable with. Put yourself into situations where you got to stretch a bit. Put yourself in front of people where you have to talk to people, to groups, but don't go into your office and work the processes.
Join INCOSE.
One of the things that the University of Minnesota has a Technological Leadership Institute, used to be the Center for the Development of Technological Leadership. And they have a program called the MOT that I was privileged to go to when I actually worked here at GD. And I would like the panelists to comment on how this might relate to systems engineering. The fundamental premise of that MOT program was that, especially in high-tech organizations where you're really dealing with high technology solutions, you're better off you need a combination of technology and management skills, and it's better, their theory was, to take engineers and teach them the business skills than it is to take business people and teach them the technology skills. Do the panelists agree with that? And how could that relate possibly to systems engineers and the leadership role?
I was going to say, I've never seen an instance of the latter, so I don't know if it's possible.
Paul started out with business and then
Actually, it was a double major, so I had the computer engineering with it.
Hey, along the same line, I've seen electrical engineers be trained to be software engineers. And one instance went the other way. A software engineer started doing hardware. But that's rare that works. Or at least it used to be. Oh, MOT is management and
Management of technology.
technology.
I know what it
Oh,
is.
yeah,
How about
yeah.
I'll answer the question differently then. Does the panelists think that we can take engineers and that we can make them be business savvy enough to step up to be that technological leader that we need on the program? What types of engineers do we need that can step up to fill that role?
I grew up thinking engineers can do anything and everything, right? I'm not sure business folks are raised with that same mindset. So system engineers like a challenge, they like solutions. Don't know from the finance side. I think, well, wait a minute, Paul, don't you have a finance background? There we go.
That's exactly right. He said it was a double major.
It significantly, yeah, let me get it there.
Explain yourself.
Okay, let's back up a little bit. I do have a double major, business administration, public accounting, as well as at the time it was called quantitative methods. And I did go back and get a master's in software design and development later on. But my role, my initial career was as a systems analyst. And I was going out and working with the business leaders and defining, getting from them the requirements essentially for what type of system they wanted, typically an application, and being able to talk with the various business leaders and understand marketing and understand finance and understand bookkeeping, then applying it to the computer environment and either doing the code or designing it, directing another group to do it was my primary role. And I still find it an asset today because when I'm not challenged at all when it comes to a program manager throwing numbers at me and why is ET estimate to complete needs to be such and whatever, and I can play the numbers just as fast as they can. And it's really an asset as an engineer to be able to be conversive in these other languages, to understand program management, the supplier contract, and it gives you a leg up as an engineer in a leadership role.
Yeah, actually my role right now is working with our finance folks, and they sure don't think like system engineers. So I'm a little bit biased the other way, I guess. Not to say it couldn't happen.
I think I should clarify my response a little bit. I've seen people in other disciplines come into engineering, but not after they've got to the MBA level. So I've never seen an MBA be able to pick up enough technology to be a technology leader.
Just a couple of comments of my experience in working at Honeywell and working my way up. the most important thing I found as I was an engineer designing various things was reading and rereading Dale Carnegie's How to Win Friends and Influence People. And I know I've had people say, oh, that's obvious stuff, but the vast majority will say it's obvious stuff and they don't practice it. The second thing, as Paul mentioned, was Toastmasters. We had engineering Toastmasters here many years ago, and I found that incredibly valuable. Something you'd never learn any other way. I took a speech course in college, but that's a lot different than a situation where every week either you're speaking or evaluating somebody in a situation in which you have to be able to take the hardest criticism anybody can throw at you.
How does the reliability engineering fits into systems engineering world?
I think reliability and system engineering go hand in hand because the systems you build, reliability lays a set of requirements upon the system, and the system engineering needs to provide and respond to those requirements just as a response to any other requirements that are limited upon the system.
Reliability engineering is another one of those disciplines where you have to convince management that it's an investment because you don't see the payback until it's too late. And by that time, people have forgotten why things are wearing out well ahead of their time.
From our newest CSEP.
So, do you think it's possible for system engineers to lead without being a leader?
Is that an oxymoron?
Well, so we've talked a lot about having presentation skills. It sounds like the Big Bang where you can make a splash and everyone sees you and respects you. Have you seen it the other way where basically you lead because you can knock on the project manager's door and say, we shouldn't do this because. And you can answer the questions for them and you gain respect that way. You mentioned, Paul, about the 3 people. It'd be nice if the system engineer is one of those people that the project manager goes to. Not because you are told that you are a leader, but because he knows you can lead. Have you seen that in examples?
Well, your point is very interesting because there are many styles of leadership. And there's also the one that we are most used to is the command and control. And I think that's the leadership model that we're talking about. How can we sell it to management? Because management wants to control what we're doing rather than having a more collaborative investment in the actual work that we're doing. So, or have power, however that works. So I think to model the leadership and to be effective, to show that your model is strong, is one of the ways to do it. You don't have to like be out in front and say, here I am, everybody follow me, kind of a model. Okay, and I think Jack Welch was one of those models that everybody held up as to not be commanded. He was like the highest level of management model that you would want to have. So find a model for your management style, study them, and then try to imitate them.
I just had one quick comment, is that you can have an official leader and you can have an unofficial leader. You might have a manager and he's supposedly the leader, but he's really a manager. But there's an unofficial leader who is really the leader, and that's who people go to. That's who the manager goes to, that's who the engineers go to, that's who the technicians go to. And so, just another aspect to answer your question.
So I'm going to ask some of the questions up here. How many system system engineering leaders does it take for a project to be successful? You know, how many system engineers that are leaders does it take to change a light bulb or something like that? But this is to be successful in a project.
One good one. One good one.
So I was just at an interesting meeting run by Human Resources, and everybody in the room thought more folks ought to have the opportunities to be leaders. So they wanted to go through leadership training and everything else. So although in the past we thought about leaders as being your one person that you go to because you respect what they have to do, there's charisma, I think leadership may be taking a different road to the youngsters. You know, with the millennial generation and everything else, that was one of the things I meant to bring up when I was first talking about those changes, and leadership may be one of those. Somebody falling asleep that needs to ask a question to stay awake? Comments are good.
We're in the saturation meeting.
So back in the early days of INCOSE, there were many discussions, if you will, on are system engineers born or raised? So I'm basically asking the same question. Can you be a leader if you've never been a leader? Can you be trained to be a leader? Or is leadership something that it just happens because people like the way you look? Poor thing.
I have found the only way to actually become a leader is to actually lead. Do what Paul said. Start small, work your way up, build your skills, build your confidence. The people who you lead will start to trust you, and they will recommend you to their bosses, and they will trust you. And that's how you become a leader. But you have to go and lead, and you can take classes, but it all boils down to actually going and doing it. Stepping out of your comfort zone, taking a risk.
So is this a nature or nurture question? I believe that there are people who are born with leadership skills inherent in their character. And then there are those that have the mantle foisted upon us. And then there are those that may not have the skill sets but choose something, that this is something they choose to do. But no matter where you're coming from in that aspect, you need to do, as Paul says, find your model, get busy.
There are those who are not comfortable being leaders and should not be leaders, but do the work. And that's in your own mind. I have had friends who were promoted into leadership positions, worked there a little bit and said, I don't like it, and went back to what they did before and were very, very happy after that. And one other comment is, I have many technical friends, people who have, advanced degrees in engineering and so forth, who went and got MBAs. And that is a very good step to give you a picture of how to manage things when you know the technical answers. Going the other direction is Kevin, yeah, it's not so easy.
I don't disagree with the others said too, but I think smarter organizations and smarter groups also provide stepping stones for leadership too. You don't have to jump in and be the ultimate leader right away. You can be a mentor to someone where you're helping people grow. You can be put in maybe a deputy chief engineer role and learn from a good leader So you have to identify, I think as an organization, you have to identify the people that have the systems thinking capability and the leadership potential so that they can be put in the places to learn and succeed and not be just set up to fail either. So I think there are also things we can do organizationally and placement-wise to help people be and grow into leadership roles too.
I think I'm going to wrap it up here, but I do have one parting comment that Dave kind of brought to mind, and as it relates to the topic at hand. And as you go about your career and you're out there pushing the next level of leadership, or even as an engineer in your area of expertise, something will eventually happen to you. Your program will go south, you'll make a bad decision, or whatever. It's not so much that you made the bad decision, first of all. It's what you do with what happened to you. Did you learn from it? If it was an unjust decision, whether you just happened to be in the wrong place at the wrong time and you were the individual there's my scapegoat, it's what you do with that decision. Are you going to get up there and prove to them that they made a bad decision on the next program you get assigned? And just show them that that's my philosophy. Is you get back up on your feet and you persevere and you just prove to them the type of engineer or leader that you are. And I think it's a very important aspect as you advance through your careers. With that, thank you very much, panelists. Excellent job. Thank you very much.